if you're tired, you can listen to afterwards. Now, basically, protocols tend to mean the method, the way computers and devices communicate. So protocols basically is obviously the method the way computers can communicate. Now there are different protocols that are involved in the LAN and WAN when computers communicate with each other. So we will discuss different protocols that we have. While we discuss protocols, obviously, I did tell you that handshaking is something that we should know. And by handshaking, what we mean is that computers need to know that are they communicating in even parity or odd parity. Now, even parity simply means that we refer to the number of ones. I did tell you this before. In case if you've forgotten, I will talk about this again. For example, we did talk about it before. So let's say I have 0, 1, 1, 1, 1, 0, 1, 0. So I like 1, 2, 3, 4, 5, 6, 7, 8. So over here, the number of ones that I have is actually 1, 2, 3, 4, 5. This basically is odd because the number of 1 is odd number. So if I need to actually transfer this in even, the parity bit that I have, this one, I will convert this into 1 because now the number of ones is even. Okay. Parity bit that we have, which is the 9th bit, is known as a parity bit because it is not one of my data bits. So these are my data bits, but that's my parity bit. So by converting this parity bit into either 0 or 1, we can change the entire the numbering of ones, the occurrence of ones to even and odd. This is what we actually mean by even and odd. So handshake, why am I talking about that? Because whenever devices or computers within a network, they communicate, they have to first of all set up whether it's odd parity or even parity. Okay. Now, we first of all have one of the most important one that comes in the exam, and that's what we deal with is TCP and IP. And probably we have heard of it many times, and I'm pretty sure you know it. So TCP/IP we discussed last time even. Just a revision again. TCP/IP is one of the protocol that is used in most commonly, 80 to 90% within a LAN and within a WAN, because where your data packets are involved, you are talking about TCP/IP. And we talk about data packets. We talk about data packets basically have 8 bits within them, right? And we also talk about the TCP will do is TCP will make sure that the data packets reach the destination. Okay, they'll make sure that they reach the destination. Yes. We also talked about that TCP will also make a sequence of the packets. Okay, make a sequence of the packets before the delivery and also after the delivery. Well, obviously what we mean is that if we are transferring a data packet, and yes, you know what I'm saying, right? So if we are 1, 2, 3, 4, 5, 6, I label all my packets. So I have to make sure that they are also rearranged in the same order once I have delivered. Yeah. So TCP takes care of all this again. Okay. It's very important that you try to remember these important points. That's it. Okay. TCP will also include the IP address of the sender and the receiver within the header of the data packet. Are you clear with me? So we have a header, and within the header, we are going to have the IP address of the sender, and we're going to have the IP address of the recipient, just like we used to have, or we still do have, those manual postals, okay, where we have to mention where it's going and where it's coming from. Okay, so then we'll talk about more. TCP tends to be a congestion control transmission. Obviously, the reason why TCP tends to be a congestion control mechanism is obviously due to the packets. Obviously, why are we referring to this? Because we should remember that there is another protocol which used to work together with TCP long time back. Still, it's being used many places. YouTube at times does depend on UDP. Rarely, CCTV cameras depend on UDP, which is UDP basically stands for user datagram protocol. Now, user data protocol does not cut down the packets, so it is not a congestion control mechanism. Okay, so and then you obviously have IP. IP doesn't have much properties. IP simply means that IP is the address where you have it has to be delivered. But TCP IP, obviously they have to work together. You're with me?
Yep.
Yeah. Okay, right. So user datagram protocol, if we talk about specifically this, okay. If there is any other protocol that you want me to discuss, at the end, you let me know, okay? Apart from this, I'll try to discuss all of them with you. So user datagram protocol basically is what? User datagram protocol is not a congestion control transmission. Obviously, the reason why it's not one is because it does not cut down the packets into a sequence number, right? So and it does not even require a hand shaking. Okay, it does not even require a handshake. So obviously, no handshaking, no congestion control mechanism. Okay, yeah, but why do we have to use it? We have to use it for a simply a continuous. We have to very continuously transmission has to go on without any time restraints. So just like you have in CCTV cameras, we use is user datagram protocol, but I don't really have to go to a lot of detail. You'll mostly be doing in GCSE. Then we have obviously is HTTP, and obviously at the same time we talk about is HTTPS. So I mean, I don't really have to discuss HTTPS. HTTP, hypertext transfer protocol. Protocol basically is used to transfer images, right? Text, right? Embedded objects, Now, what do I mean by embedded objects? Such as your Java beans or your graphs or your 2D animations. Okay, these are embedded objects. They're within the programming languages. Then you have obviously is uh, style sheets. What's wrong with which is actually known as CSS. Then sounds. Then you have uh, videos, etc. So all these, when you open up a website and when you see all of this within a web page, this all is being transferred with the help of HTTPS or HTTP. HTTPS is simply, obviously, HTTPS is secure. Okay. Now, when we talk about security, we deal with something which is known as is a. Do you remember asymmetric encryption?
Not top of my head. No.
What was asymmetric encryption? Okay, we did talk about it, right? So asymmetric encryption, there were two. There was symmetric encryption and there was asymmetric encryption. Okay, so why is it should I talk about it, right? So what happens in let me explain it. It's a pretty easy concept, and I'll explain you with a very concept. Symmetric encryption basically just had one public key. Now the problem with symmetric encryption was public key would be with everyone, and so I mean there would be no privacy of data. So why would I use a transmission where everyone knows the key and everyone can get it? Well, it was not a very safe way, obviously. We had to come up with a way, and this better. And this is where HTTPS came in, and this is where the difference between HTTP and HTTP came in. Let me give you one good example. You are the user, okay? You type www.mrsaem.com. mrsaem.com goes to the sends a request to the recent DNS server. The DNS server sends the request to my hosting server. I will name it as H is the hosting server, and I will name C as the client. So when the client sends a request to the hosting server obviously will see from where the request is coming from. In asymmetric encryption, why is it safe? I'll tell you why. Because over here, what we're dealing with, the client will have two keys. One is known as public key, and the other is known as a private key. I'll make it private, PR, and LPU is public. So public key and private key, how come they play a very vital role in making sure the data is safe? Well, I mean, I always explain this in one example, is that it's just like you have a box and the box can open up with two keys. One key is the public key and the other key is private key. So just like a normal keys that you have of copper, you have this box, you open up the box and your box is opened up. This open box, you will send it to the hosting server and the hosting server receives your box. Fine. In the middle, anyone gets your box, no problem. There's no issue, right? Because there's nothing inside. It's an empty box. Once the server receives your box, the server will see it's coming from you. Okay, fine. It will see that it has public and private key. Okay, right. So it will do is what it will put your request, your attachment, your message, whatever you're requesting for, the web page data, it will put inside it. And then what it will do is it will close the box. Okay, I can't draw how to close the box. Anyway, let's say the box is closed. Okay, and the two keys are here. So the closed box, once it's closed, it comes back to you. So now remember one thing, once the box is closed, the only person who can open up the box is you. Because remember when the story started, I told you the only person who has the public key and the private key is you. Yes, the public key might be with everyone, but only you have the private key. So once the box is closed, only the person who has the private key and the public key can open the box. So this means once it comes back to you, you have both keys and now you can open it. This is why when I send a request through an HTTP website, what happens is at that instantaneously, my browser will generate a public key and the private key through an HTTP session. And this is where the same process works on. I hope it's a bit clear. And this is asymmetric encryption. So when we talk about asymmetric encryption, we are actually referring to HTTPS. Remember that. Okay. Whenever we talk about, you might have heard of digital. Have you heard of digital certificates? Now,
I don't think.
yeah, digital certificate is this. Digital certificate is when you get a private key in public key. So HTTPS, digital certificates, and asymmetric encryption, they revolve around the same concept.
Yeah. So is HTTPS private?
Sorry?
Is HTTPS private?
It's fiber or use fiber?
No,
What?
HTTPS private.
Uh, it is. It is. Yes, it is.
Okay.
Could you explain how? Think over it.
How to secure? Is
Yes. It,
that it's more? Yeah.
mhm. Okay.
But another question, a question around that. How does the how does it make it secure?
Okay. How does HTTP makes it secure? I just told you. Like, just 1 second. Listen. Right now, what I do is, I just give an example. I open up MrSaem.com. Okay, I'll just open up Mr. Saem. Not the login. I open the website. Now, what happens right now? I've sent a request. The request goes to the Mr. Saem server, and right now,
Yes.
you see the padlock. The padlock is closed. If I click on
Yeah.
over, this says that the connection is secure. The connection is secure because if I click over here, you see it says HTTPS. Can you see that? Yes. And secondly, I'll just show you that if I click on connection secure, certificate valid, you would somehow see over here is that I have this key generated. This is basically my private key generated. Can you see that? But obviously, it's not very easy to decrypt it. This is generated right now. Once I request this again, I'll refresh this again. I'll refresh this again. So this request goes again. So now what happens? Let's have a look at this. You would see is, do you see this? Maybe you didn't notice. The key has changed again. So every time these hexadecimal values will keep on changing every time. You get my point?
Mm.
Now, why are we generating these? The reason why I'm generating these is because only my computer, my browser has generated this, and only I can decrypt it once I get the message back. Anyone in the middle can't do it. Because if anyone in the middle does get it, the person might try to put a Trojan horse or a worm or something within this web page, and this would make it very unsecure. This is why Google make it compulsion that everyone has to launch a website that has HTTPS at the back. Yes or no?
Yeah.
Right? So this is where we talk about asymmetric and symmetric encryption. So yes, one of the most important part of HTTPS is talking about this. Then we have obviously is FTP, which probably you have heard of and you know. It's basically file transmission protocol. File transmission protocol. And file transmission protocol basically does is that obviously it helps you to, okay, helps in the uploading and downloading of the files from the client to the hosting server. I'll just show you that, okay? I hope I have the previous Dreamweaver version. 2020, I don't know. I'll just see if I can show you. Because if I demonstrate this to you, it will be a lot better. In case if I don't have the credential, then I won't be able to show you. So if I come into, let's say, my files. So here we go, Mr. Saem. Okay, right, that's my website. So over here, you can see is obviously I can't show you on the net all my details. But over here, what we do is we enter the FTP. We enter the FTP address, ftp.mrsaem.com. We enter the username and the password. Okay. We enter the root directory. So once I click on OK, I will directly get connected to my server. Now, this information that I have, this information that comes in, has been given to me by my server. They say, okay, that's the FTP address. This is from where you can access your folder. This is the authentication technique that we are giving you, and this is the root directory where you will be putting all the content of your website. So what
Yeah.
I mean is that this is what FTP is. Okay, it's file transmission protocol. It helps you to upload and download data. Okay, right? So it basically works with proper and secure methods of authentication, right?
Yeah.
Um, Techniques, right?
Yeah.
Okay, and works with a session plan. Well, what do I mean by session plan is that if you don't use it for a while, it will log out itself. Uh,
Yeah.
then what we have is what are we left with? Well, am I left with any other protocol? You can remind me.
Sorry?
Am I left with any other protocol?
Any what?
Am I left with any other protocol?
No.
Okay. If there is, I'll share with you. Okay. Now, yeah, I also talked about security. So when we talked about digital certificates, when I talk about asymmetric encryption, these
Mm.
are topics that come within the security as well. You get my point?
Yes.
Okay. So when we talk about file transfer protocol also works with different authentication techniques. That's also security. You get my point?
Yes, yeah.
Okay. And what else? Just 1 second. Just 1 second. Then we have is
Sorry, my mom's making, very rude comments to me. To me, just make him go out of the room.
sorry.
Go ahead.
Are,
Do you
are
have
you
a sibling?
are you talking to me?
Yeah, do you have a sibling?
So sorry, I could not. There was interruption.
Do you have a brother or sister?
Yes. Have you done pop? Remember, is pop in your said? Have you done it in your class?
No.
No, I mean,
No.
if there's any protocol, because you know what, there are lots of protocols. Um, so I don't know what is the limit in which the teacher might assess you on that. There's
Yeah.
SP, there's pop, there are lots of other protocols as well. But
Mm-hmm.
I don't know if you've done those or not. But these are the most in our syllabus. These are the one
Okay.
important.
Okay.
Do you have any list or something you can tell me? Topic, or maybe you made some notes, or you can anything you want me to explain regarding this?
Oh no, I just think this topic list the other day. That's all like I need to learn with my test.
Sure,
My
sure.
exams in June the 12th.
Okay.
Mm.